Right, thank you everyone for coming. If you guys don't mind, I'm going to take a selfie real quickly. There's proof that I was here and you guys were here. Otherwise they won't believe me. Smile. Oh, thanks a lot. Okay. All right. Okay. Yeah, welcome. Glad to be here in Düsseldorf. Welcome to the talk DDOS as a service using JMeter, Docker and AWS to load test your application. So as always, a bit about the speaker. That's me. It's me over there enjoying a beer in Berlin a year ago. I'm originally from Aruba. This is the flag of Aruba. That's an island in the Caribbean, but I moved to the Netherlands 10 years ago and I live in Arnhem at the moment. I work as a software engineer and I've been working 4 years at Luminous Arnhem. And I do Java and stuff. It's not really important. Contents of this talk. Load testing. What is load testing? Why should you consider doing load testing? And how could you go about doing that? Should you decide to want to do it? But before I get into load testing, first DDoS. Why is that in the title of my talk? Well, first I have to explain what a DOS attack is. That stands for denial of service attack. That's basically when an attacker wants to either decrease the service that an application is providing or completely stop it by sending a lot of information, a lot of requests, a lot of load to a system. And a distributed denial of service attack is when this is done over multiple nodes. So for example, here in this illustration, maybe an attacker somehow has gotten access to some nodes that will send a lot of load to a server, which then makes it respond less quickly than it usually would, or maybe not at all. And the reason why I did it, I put it in the title, is because when I was load testing our application, it felt like I was performing DDoS attacks on our own application because I broke it a few times. So that's why. But also, what is load testing? Well, it's kind of like this, except the face at the top is more friendly, with the idea that it doesn't necessarily want to break your application, but it wants to find the limits. It wants to find how certain load will impact your application. So load testing, how does the system perform at a given load? And also some people like to use the word stress testing as something else, which means how much load does it take to break your system? So at the first one you could say, if I use an amount of requests, then the performance is decreased by 50%. And the other one, stress testing, would be if I do 1,000 requests per second, then the system breaks. For this talk, they're both considered in just the same load testing. Example of how the load testing flow would go, you would establish some kind of acceptance criteria. So you would say, I want to be able to handle 100 concurrent users or requests per second. Forgot to set it there. Then the request should still only take 100 milliseconds. That's a kind of goal that you would want to achieve. You would create a test that simulates 100 concurrent users or requests. You would run that test, you would analyze the results, and if the acceptance criteria fails, then it's time to go into your monitoring, logging of your tests and your application and everything in between to see what the bottleneck is. If your acceptance criteria succeeds, then you're happy and you can move on. That's what it is in a nutshell. Why would you want to do this? I'm going to explain this by giving 3 scenarios that happened to me while we were load testing. The first one scenario is we had an application, a mobile application, and we ourselves built that white square over there, the system under test. And the system is hosted on an environment by a third party, and there's some kind of network component, doesn't really matter, but it's in between the communication for the mobile app to our application. And this was running on an acceptance environment, because we also have a production environment. The idea of the test was that you can see at the top left that I replaced the mobile application with a load testing tool that was going to send, let's say just for example now, 1,000 requests per second, and we would be able to test how our system works under these conditions. The idea of these two environments was that if something were to happen, and let's say anything breaks, our system under test or the network component, then our users on production would still be happy. That's the idea of multiple environments. Except that wasn't the case, because for some reason the third party decided that, well, we weren't that far yet in the number of users, so they were trying to skip costs, and they had one singular network component, and no one thought about this for a long time. And until we ran these tests, we broke the acceptance environment, but we also broke the production environment. So that's one. But the good thing is, because we were performing this load test in such a early part of the entire system, we were able to still make sure that this was correctly configured by the time we had a lot of users. So that's one scenario. So users weren't very happy. Scenario 2, we have one system under test, and we have IoT device, this thing over here, and they communicate via TLS, and they communicate encrypted messages to each other. So you can imagine a lot of IoT devices just installed in people's homes, and they're just all communicating with our system under test. So what we did is, instead of the IoT devices, again, we had our load testing tool, and it would do this a number of times. It would just communicate with our system under test. And after the test, we just have like live monitoring on our system, and we saw that the heap usage for application went all the way up to 3 gigabytes. And even though the test was finished, it never went back down. So it was just stuck at 3 gigabytes. Turns out that each TLS session that we had cost a fixed amount of megabytes, and these cannot be garbage collected, because we hold the references to these TLS session objects so that we can easily communicate faster, because otherwise you would every time you have to do a TLS handshake, and that costs a lot of time. It could not be garbage collected, and this information we could use to predict how much memory we would need for the future. So let's say in the future we expect to have 100,000 users or IoT devices, then we can predict roughly the amount of megabytes we need. So that's one thing. Another scenario, third one, same application again, a bit more details now. This TLS communication happens over a WebSocket connection, and all of those WebSockets were being connected to a certain port on our system under test. And we were, again, with our load testing tool, we were testing it, and we tested 25,000 connections. Everything was fine. 50,000, no errors. And then at 75,000, something happened. We had around 17% errors, and it wasn't just one time. We tried it a few times, and it was constantly the same amount. It turns out that you can only have 64,000 open TCP connections on one port. TCP is a WebSocket over TCP. So the solution was to open a port next to it and add a load balancer that sends the data to both ports. This was also something that we tested when we only had like 25,000 live users. We tested 75,000 in our load test, and we were on time to make all of this happen by the time we reached that number, 64,000. So before I show that sheet, these are just like 3 scenarios that actually don't have anything to do with your application logic, what you wrote down. It's all network configuration that can go wrong. But there's also things like memory leaks or problems with queue logic, maybe not enough memory or CPU in your hardware. You limit the number of file descriptors that you need in order to have the number of open connections. Maybe you expect that your system will automatically recover after it breaks, and after you break it with your load test, you figure out, hey, it doesn't, the mechanisms don't kick in, and things like that, logs, and a lot more. So that's why you should consider doing load testing. How can you do that? There's a number of ways, number of tools to do that. Here are some of the logos of some of the things that I'm not going to talk about. I show them anyway. Gatling is very popular. Blazemeter also, I think. But in this talk, as a title already spoiled, I'm going to talk about Apache JMeter. And Apache JMeter is a tool to perform load tests. So instead of talking about it, I'm just going to give a live demo. And we're going to do that right now. So this is JMeter, I hope. Yeah, it looks good. It looks a bit outdated, a bit clunky, but it does a job, right? It works. This is how it looks like when you just open it up. So I'm using Apache JMeter 5.1 right now, and it's a clean new test. And over here we have the tree view, which we're going to add the steps in our test that we want to run. So it also always starts with a test plan. You can give it a name, and there are a few things you can click on. I'm only going to talk about the configurations right now, the minimum that you need to run this test, because there's a lot of buttons to click on, and feel free to do that on your own time. So on the test plan, the first thing I'm going to add is a thread group. And this is really what makes it the difference between just your a normal REST client like Postman, which you can also do REST calls, but you only usually do one. I believe maybe Postman also has something like that. But the reason you would use JMeter is because of this, the thread group, where you could run a number of calls in parallel, so not sequentially after each other, just next to each other at the same time. So that's what the thread group does, and you can add here the number of parallel threads that are going to run whatever we put inside the thread group, so you can put whatever you want here. But for now, I'm just going to leave it at 1. The ramp up period in seconds, that is the time it will take to start all of these threads. So for example, 1,000 threads will be started in 1 second. It really depends on the device you're running on if this will work or not, because if I put like 1,000,000 here and I have to start in 1 second, then I know on my laptop it's not going to work. So I need to spread it out a bit over time. 1,000 will work, but for now 1. Ignore everything else for now. So inside the thread group, I'm going to add the test. And what I want to be testing right now is an HTTP request. So we're going to call a sampler. And there are a lot of options, but we're going to just do an HTTP request. And you can see our tree is expanded with an HTTP request. You can give it a name if you want. I'm not going to do it. Protocol, so HTTPS in this case. Let's just do something random. It's not going to work. And over here I can open the terminal. Clear this. I haven't run anything yet. Here's where you will run whatever is inside your tree. So if I press play, oh, it says you have to save it before running. That's fine. I'll just call it live demo.jmx, which is the extension for a test script. Save, and now it runs it. And thread is started, thread is done, thread is finished, notifying test listeners of end test. This doesn't tell you anything about what happened with our test or what's going on. You need to add a listener in order to see what's happening. So at the thread group, I will add a listener. And I think it was the tree one I need. The view results in the tree, this other first one. If I play it now, then we will see our request here. And we can get all kinds of information, but the important thing is unknown host, because this website that I put in doesn't exist. So now we're going to make it work. I have a web application running somewhere. It's not really important what kind of application it is. I'm just going to steal this for a bit. This is the URI that I need. And also the resource. This path resource. So now it's going to do a call to this /press for presentation /resource. So if we clear everything and we run it again. Oh yeah, okay, now it doesn't say unknown host, it says 401, and that's because I also put an if statement in my code that it needs to have an authorization header. Otherwise, just return 401. So now we have an HTTP request, but we also need, usually you would want to add headers to your HTTP request, so you would add a config element to your HTTP request, and we will add headers, and it's just a key value pair. So I'll add one now, authorization, and my if statement just checks if it exists, so it's not really secure. But it's just for demo purposes. So if you run it now, it should be green, I hope. Yeah. And we can see, okay, we sent the request to here, and everything is green, and that's fine. Of course, maybe we want to run more than just one call. That's where we would add a loop. So we also have a lot of logic controllers in JMeter, JMeter, and now I'm going to add a loop controller. I'm going to put it up here, and I can put 10, and I need to make sure that my HTTP request is inside the loop. So again, we have the test plan, one thread group, loop controller with 10 HTTP requests with headers. So if we run it now, it should call 10 successful calls. Okay, so that's 10, but these are sequential after each other, so they're not in parallel yet. If we would want to do that, then it's as simple as just putting 10 here. So now we would get 100. But 10, they're running 10 threads next to each other, 10 calls in parallel. Running that again, maybe I'll just kind of close the terminal. Play. And yeah, you have to believe me that this is 100. I can also add another listener, which gives me a bit more information about the total. It's a summary report. Put it. This doesn't really have to be out here. Should be part of the chat group. Yeah. If I run it again, then we will also get like the number of samples should reach 100. We get the average load time, minimum, max, standard deviation. Number of errors, this point 0%. What I also did is the endpoint can also take. We also have another endpoint where we can add a delay in it, so we can say 1,000, just a number. I did this for. Also for this demo, so you would put 1,000 and then it just waits 1 second, 1,000 milliseconds before it returns a response. So just to show that this works, I'm gonna put this back to 1 for a second, and see what it does. You can see, yeah, the load time takes a bit longer than I expected, but it could be the internet here. I'm not sure. But it's sending now the request with 1,000 behind it. Now let's say that we wanted to add a random number in the loop. We can do that. We get a config element, a random variable, and we can say a variable, we're going to give it a name. I'm going to call it delay. Do from 100 milliseconds to 1,000. And then this is how you would add parameters. You would do a $sign like this and then the name of the parameter. And if we check now, clear, then we're going to see that it's for every item it's going to call a different number. So this one was 591, 418, and so forth. What else is interesting? Oh yeah, so we have now here 1, 2, 3, 4, but let's say, for example, we also have a few of these things, like 10. We want to add them in some variables. You can add config element and then user-defined variables. I always put them up here. And then you can add whatever variables you want, like say, for example, path, and then /resource. And then I can just refer to it here as path. And that also works. So then you can do that for everything that you use after this. It becomes part of the scope. Let's see, everything's still working. Oh, these are the new ones, forgot to clear it. But it's still working, everything's still green. Now let's say, for example, that you don't want just one static 1, 2, 3, 4, but for example you have a list of CSV files, as I have right here, and you want to constantly use a different one, a different UID or a different token, then you can also read this in. So this, I think this is the last one I'm going to show. CSV dataset, I'm going to put it up here, and you can browse for the file. Take this one. And you have to give the variable names, comma delimited. So I'm going to do number and token. So this corresponds to this number, which I don't really need, and the token, which I need. And then it's available here, so I can use token. And if we play this now, then we should be able to see that it uses a different token every time. And the request headers. Oh, I forgot to put the $sign, I think. Yes. Also, this should be up here. Yeah. Okay. One thing of JMeter, you should always just let it finish. Don't stop it, because you're going to be waiting a long time for it to stop. So Just gonna patiently wait. Shouldn't be much longer, I hope. Really don't know why it's taking this long, but did I put something 10? Oh, it's done now. Okay. Maybe I'll just do one, just to show, two, just to show that it uses different different headers. And I think then that's basic what you can do, and then you can scale this up as much as you want. So you can put 100, 1,000, try it out till your laptop doesn't work anymore, and then you can get a second laptop, and then you both can press play at the same time and keep on going. I'll open now one that I already created, completed test, just to see if I have everything. This I'll explain in a bit. This I have, I think it looks about the same. Oh, I also added a delay. So for every loop, there's also a short delay between requests. What else did I want? Okay, so the JMeter tool is usually you don't use it for running the actual tests. You just use it as a test designer, and it will create a JMX file for you, and you can run it via the command line, which I'm going to do now. So I don't want to install extensions right now. Anyway. Let's close this one. So I have a script. Ignore this part for a bit because I'm having problems with my path environment. But you call JMeter with this flag, which means non-GUI mode. So that means now we're going to run just JMeter as a command. The -t is the test script, which is the completed test, which I showed you guys. -j for some reason is the log file for the output for JMeter. The XML file, the L is for the results. So you get like an XML output for every call that you do, every action. These are some things that you can ignore that just explain a bit of the format. And this is interesting. These things are variables that I can give it right now. Like this is the file for the CSV. This is a number per client, number of requests per client. Which then, if your tests have this notation, which is also kind of weird, but $, then this with 2 times underscore with P for parameter. And this, if it has the same name, then it will be using that value for this user-defined variable. If it's not defined, then it will use a default of 10. So this is what that means. So this is nice because it means that I can just switch a few things here and I will always run a different test. Just to show you how that looks, I really want to get rid of this. Oh, there it is. All right. So I will just run my script, which I think let's just run this. See what it does. Did I have the host? Yeah, that was set. Yeah, so it says creating summarizer, which will print out in a bit how many errors we have. Created a tree, so that's the tree of all our test items based on our JMX file. Timestamp, and now it always shows this in case you want to stop it. And now it's starting up, and in a bit it will show the number of actions it did and the number of percentage of errors it has. So right now we're running, let's see, just 10 requests. 10 clients, so it should be 100 in total. So this is 61 things that it did, so 61 requests, and it had 100% errors. So that's not that good. Wondering what I did wrong in this case. Well, we should be able to see. Okay, so this is a good example. I wasn't planning on this, but it gives you a log file, but also the XML output, and we should be able to see what goes wrong. Response data. Oh, succeeded. Oh, that's weird. Call succeeded. For some reason it thinks that this is not... Oh, I know why this is. 100% errors. Something I forgot to explain is, of course, we talked about the acceptance criteria that you need to set up. That's where you can set it here. In for HTTP request, I have a timeout. So if it takes longer than a certain amount, then it will consider it a failed request. And right now, I think I have this timeout at 2 seconds, if I'm not mistaken. Yeah, 2 seconds. So all of the calls are taking more than 2 seconds, as we already saw for some reason in here. Now it's gone, but you guys saw it. So I can't explain why it doesn't work, but you can see that the error mechanism works in JMeter. I'm going to continue because I don't have time to debug right now why my application doesn't work. But this is in a nutshell how JMeter works, and you would run it from the command line usually, and not from the GUI, because the GUI also takes extra resources, and that's not very useful. So now you think, okay, if I have this, then I can do load testing, I'm done. What else would I need? Well, if you want to really reach a high load, then this is going to happen to your laptop. You're going to have problems. You're going to reach a CPU limit, memory limit, number of native threads that you can start up. The portability also, what I mean by that is that if you want to run it again on someone else's computer, your colleague's computer, then they have a different version of something that doesn't work. Or your network, from where you're running it from, maybe doesn't work properly, or can't handle the load, and more things. So it will work through a certain extent, but eventually you want to scale up to a bigger load. So this is where this comes in. We want to have a distributed test. We're going to make use of Amazon ECS, and we're going to be using Docker. So we're going to run JMeter inside of Docker, and that makes sure that the portability part is fixed. And Amazon ECS is going to offer us infrastructure to run this. Docker in a nutshell, well, Docker container, it gives you the option to create a container, a contained environment where you would just say, I want this OS, I want these specific versions of JMeter or whatever else you would need, and then just run this command. That's basically what it does. And if you have Docker, then it doesn't matter if you're on laptop, on a Mac or Windows, it should run the same. It's the idea of Docker. Amazon ECS, three things that you need to know about Amazon ECS, 4 things. The name, it stands for Elastic Container Service, and 3 terms. Repository, that is the Docker repository where will contain our images that we're going to push to it. So we're going to create an image, we're going to push it, and then we can run it on multiple instances in the cloud. Task is a description of how to run the image, so it's going to be telling it, oh, you should run this Docker image with this number of CPU and memory and other environment variables and stuff like that. And a cluster is just a set of EC2 or Fargate, I'll explain those later, but just instances of virtual machines running somewhere in the cloud. These 3 things together will make our test run, and this is my attempt at trying to draw it out for you. So we have a repository with our Docker image. There's a task that links to the Docker image, and all these instances are running that task, which then points to the Docker image. So eventually they all end up running our JMeter script, is what I'm trying to say. Now it's time for a live demo again. So I'm gonna, oh, it's almost time already. No, I was there for 50 minutes. Amazon ECS. So I'm going to log into Amazon, and I'm already on ECS. I'm just going to show it. This is how it looks like when you log into Amazon, and you would just type in ECS. Oh, it's already here. And this is ECS, and you see the 3 things. There see more things, but 3 things that are important: repository, the task definitions, and the clusters. Repositories is the first. We want to upload our Docker image. Before I show this, I should maybe show the Docker image that I have, Docker file. I have a Docker file here. This is the file that you use to create a Docker image, which describes the OS that I want and all the versions of things and environment variables that I want. So OpenJDK with Alpine Linux 3.7. Some basic things I need to update the Alpine. This is important, all the environment variables. So I want JMeter to be saved here inside the container. I want this version of JMeter. Ignore this. These are some. This is where I want to put the test file, the tokens, just some variables. And these are the variables that I showed you guys when I was running it from the command line. So number of requests, 10. These kind of things, the host and the resource. I'm putting it here. This is where it's going to get JMeter, so it's going to download it. with this specific version. It's going to put it at the JMeter home that we set here. It's going to copy the test JMX and copy the tokens into the container, and then it's going to run JMeter with the same way I showed you guys from the script, but also it's going to echo the log file and the result file so I can see exactly what happened. And this is just a description of what we want our Docker container to do. And when you create a repository, you just go here, you give it a name, like demo, ignore the rest, and then that's it. You have the repository. You click here, and I really like this. It gives you exactly the commands that you need to run in your CLI to have an image pushed. So to do this, you need to install the AWS client. So you have to look that up, how to install it. But when you have it installed, then you can run these things, and you also need Docker. I'm not going to do it now because it takes a long time. I have one already prepared for the JCON, which I have a few images. This is the latest image, and so it's ready to be used now by a task. I'm going to start talking a bit faster so I can make it. Now we're going to go to task definitions. That was the second thing. And a task definition, I already have one ready, but I'm going to show you how it is when you create a new one. Here you have two options, Fargate and EC2. Fargate is the variant where you don't actually have to start up any instances. You just say, I have a task, it takes this many CPU, this many memory, and Amazon itself will make sure if to run it on one or multiple systems. You don't have to think about it. You pay for the task size that you set up. For EC2, you have to pay for the resource. So you have to say, I want to start 5 VMs with this many memory, and then you can assign your task to those 5 that you started. So it's a bit different. I prefer this one because you don't have to think at all about the infrastructure. So I'll take this one. You can use either. And then you give it a name. Just call it live demo. You take here always the ECS task, which is the default. This one you can't change, so we're not going to talk about it. Just leave that like this. And this is where you would choose the task memory and the CPU. And it's always hard to guess what the right CPU and you should just start with it, and then when you run it, I'll show in a bit where you can see if you're reaching the peaks of what you set in. So if you choose here 2 gigabytes, for example, it will tell you, well, a valid range is between 0 to 5 to 1, so I'll just take 1. So this is what you're going to be paying for whenever you run this task. And you can look it up what exactly the price is. It's not that much. This is where you add the container. You would give it a name. I'm just going to call it live demo. And I copied the image URI a bit ago from the repository. There's a button to click. Basically, everything else you can ignore, except for, this is everything. The environment variables, which should be these things that you would want to change per test. So maybe the request for client is now 10, but maybe I want to run a test in a bit where it's 100 or it's 1,000 or whatever I want. So everything that you would want to change later on, you could add it here as an environment variable, which will be sent to Docker, which again will be sent to JMeter because we linked it up. So it will override this one, which will then be used here, which will be used in our test because it's defined here. I'm not going to do that one by one now because I already have one ready. So just to show you guys, I have a JCON one, and I also use 2 gigabytes and 1 CPU, and I have all of them written here with the host and the resource and the timeout. Okay, and that's a task definition. And the last thing is a cluster. You can create it here, and this one is for Fargate. So if you want to use Fargate, you have to choose this one. Otherwise, you have to use this one, and this is for if you have a Windows container. So I'm going to use this. Give it a name. I'm not going to create it anyway. Here, you can choose to create one, unless you have one already. A VPC is just a virtual private cloud. I'm not going to get into exactly what it is right now, but you need one. And if you already have one, because you've created a cluster before, you don't have to do it. Otherwise, you click on this and just leave it like it is. I've never looked into this, never had to, so neither should you, I think, unless you run into problems. And then you click create, and then we'll create a cluster for you. Of course, I also already have a cluster ready, the JCON Fargate cluster. This is the cluster. It currently doesn't have any services. A service is something different than a task. It's something more long running. I'm not going to talk about that now because for load testing purposes, we only care about tasks. And the metrics, we can also check how much CPU and things we've used. This is the important part. We're now going to run our task that we defined. So we're going to say run tasks, and you can choose the two types. Fargate is going to say, hey, this one is not a Fargate task, you can't use it, that's correct. I'm going to use the JCON one, the latest version, which you can also use. Oh, sorry, this is a platform version for Amazon. Just always use the latest one. Cluster is the one we just created. The number, I'm just going to leave it at 1 right now. This is not important. This is the VPC I created, and subnets I also just choose always the first one. Haven't had any issues with it yet. These two are important, otherwise it's not gonna work. You need to have a security group that, this one I created specifically for this test. Security group is just basically like a firewall setting that tells, that it uses, that tells you which inbound traffic and which outbound traffic is allowed. And by default, for some reason, it doesn't allow any outbound traffic. So what would happen is that your test would just fail because it needs to perform a lot of load to some server. So this one allows outgoing traffic. I choose that one, and it's also important to put this on enabled, otherwise it won't work. I haven't looked into it yet why it is. So, and over here, this is where you can override all of your settings. So now I run in 1, but maybe I can run it with 10 number of requests. So now we're going to have 10 clients running in parallel, but just still one instance and running 10 requests. So if I click on this, they're probably all going to fail because for some reason it's taking more than 2 seconds. But we can see, okay, now we have a task. It's in the provisioning state. And you can keep clicking on this for a while. And it should go into pending state soon, otherwise the demo is finished, okay? In the meantime, I'm going to open another service, the CloudWatch service. That's something that I forgot to show. I'll show really quickly. Is that when creating your task and you go here, it automatically already sets up logging for you. So it says here, storage and logging, automatically already configure CloudWatch. That means that all of your logging is automatically being sent to CloudWatch, and you can just see everything that's happening in your test over there. So it puts it under ECS, and then the test description name. So that would be JCON. So if I go to CloudWatch, this is another service where it sends all your logging. It's not only for ECS, but also if you have Lambdas or API Gateway, any services you use, you can use CloudWatch. You would go to logs. I have a lot of them. I'm going to, I think it's on the second page. ECS and then JCON. And we can see that today is the 25th. So this is the one that just ran now. And if we check really quickly back here, back. The task is not, it's already done. And now is the question, what happened exactly in the test? This is a bit unfortunate. Can't I go down? Okay. I have to do like this. For some reason now it was okay. So I think Amazon, because also my backend is also running in AWS, so maybe since it's running from the cloud, it's going really quick. So it's going faster than, 1 second. We could, for example, I think it was HTTP sample or something like that. But we could, for example, do a search for this HTTP sample. You can see load times still 2 seconds. So I'm wondering why. Maybe that's a fault on my side that I have the timeout not configured correctly. But now it's showing that it's getting a response. So just going to continue for now. So that was one. And if you want to do more, then you would just do the same again. And you do 10 of them now. Same story again. And now you're probably wondering, yeah, I don't want to click all the time in these things. It's also possible to do all of this via the command line. So once you have the AWS thing ready, you just have to give like a few parameters, like which cluster, which task, and all those things. Network configuration like we're doing right here. and then you can just run it from the command line, so you don't have to click all the times. Even like this, it's pretty handy. So let me think. We have 10 instances and then 100 clients doing 10 requests, and then we press run.
How do you resample the test results?
How do I? Resample? Yeah, so exactly. So you have test results, and that's the last part that I'm going to talk about. That now we have 10 things, and you don't want to be clicking one by one in all of these things and looking into them. So what we have, and just gonna, okay, they're eventually all going to run. They're all going to be separate log files. So every one of those tasks is going to have a log file here. So if I refresh, you're going to see the 25th, 1654. So this is the new set, and this is the one we ran by itself. These are the 10 sets, and eventually maybe you have 100 of these, or I don't know, and you don't want to do all of them one by one. You can use CloudWatch Insights, which you can do a kind of a query language. You can say, for this log group, give me example the number of errors, and I already looked into it here. I can't explain exactly how it works right now, but just to give an example, like this is the number of errors per container. So like this, and it gives me the error percentage, filter messages that have, yeah, this is not a good example. Maybe I'll take don't have time to explain that right now. Maybe I'll take the average latency. That one is a bit more easier to explain. So the latency just gets the HTTP request. It takes this parameter, this star will be latency, there's a number there. And it's going to take the average, and it's going to averages per second. So if I take the last 15 minutes for this log stream and I run the query, and you can ignore the visualization. The important part is that we have every second. See, this second it took an average 1.1 second to respond. This second took this, and this second took. So yeah, maybe this is not a very good example, but you have the option here to do queries over all your logging and then combine together to see if you got any errors. You also can do things like, I have here an example, error type distribution. So you could check, for example, first how many errors you have, and then you can check what are the errors, what are the most common errors that I have, and based on that you can start to look at what the problem is. I need to start to wrap it up, otherwise I'm not going to finish. But that was in a nutshell like how you could set up AWS to do this. A bit about pricing. If you're using EC2 instances, and then it depends on the instance, like they said, so you pay for the resource. An example is this one, which has 2 CPUs and 8 GB, cost about this much per hour to run. And Fargate depends on the task. So also here's some numbers. And you also pay for data transfer, so not only for the test, but all data that comes in. In this case, for our test, it doesn't really matter. But if you would run something else on ECS, then all data coming in is free, but all data going out has a price. But you will only pay for the test that you run. For example, Blaze Meter that I showed before, you have to pay like an annual subscription or stuff like that. So I think this is pretty, you're not going to be running it every day, the load test, unless you want to. But, yeah, takeaways. I hope I've convinced you a bit to maybe start load testing. I think there should be something of every product's backlog, even if you have only like 20 users. You still want to know that your application will run perfectly for 20 users. You would find unexpected issues, not only with your application, that maybe it's perfectly programmed, but there's a lot of things going on around your application that maybe you don't know about. It also brings you a peace of mind for you and your clients to tell them, yeah, you've already tested with 100,000 connections per second and it works. There are many tools you could use. I show JMeter, but choose whichever you want. They all do the same thing. And Docker and Cloud works really well for large scale tests. You can use also Microsoft or Google or Oracle or whatever cloud provider you want. I think all of them have some kind of Docker component in them. Also, if you're missing some information on dzone.com, I also wrote a blog post about this, how you can do it. So there's also a bit more information on there, and there's also a link here to a video of this presentation I gave before. except I did it with EC2 instead of Arcade. So you can also look at that if you're missing any more information. That was the presentation, I think. Thank you.